For the longest time, we've built software on a really simple idea. We give it a set of rules and it follows them. Period. But what if we could level up that relationship? What if instead of handing our systems a rigid instruction manual, we could just tell them what we want to achieve and let them figure out the best way to do it? Well, this explainer is all about that huge shift, moving from simple rules to powerful intent.
So let's get right to the core of it. A classic business rule is, well, it's static. It's brittle. It says, if this specific thing happens, you must do this other specific thing. No exceptions. But a business intent, that's a goal. It's way more flexible. It says, hey, when you're in this kind of situation, your job is to achieve this outcome. And that little shift in thinking, it's everything. It gives the system the freedom to choose how it gets the job done, which is a complete game changer.
So that's the big question, right? If we want systems that are more adaptive, more intelligent, and just smarter, how do we actually build them to chase after goals instead of just blindly ticking off a list of commands?
Well, the answer, and you might not expect this, comes from a pretty wild place, the high-stakes world of military fighter pilots. That's right, the core idea we're going to unpack was created way back in the 1970s by a legendary U.S. Air Force colonel named John Boyd. And he wasn't thinking about, optimizing a supply chain or managing a network. Nope, he was thinking about how fighter pilots make life-or-death split-second decisions to survive in a chaotic dogfight. And what he came up with was the OODA-loop. It's so elegant and so powerful. Here's how it works. First, you observe what's happening. Where's the other plane? Then you orient yourself. What does that position mean? What are their options? What are mine? Based on that rapid analysis, you decide what you're going to do. And finally, you act. You pull the stick and execute the maneuver. The pilot who can cycle through this loop of observing, orienting, deciding, and acting faster than their opponent, that's the pilot who wins.
Okay, so fighter pilots, cool story. But what on earth does that have to do with code? Well, researchers realized that this decision-making cycle was the perfect foundation for building intelligent software. It just needed a couple of key upgrades for the 21st century.
And this is what they came up with, the extended OODA-loop. Now, I know, it looks a little more complex than the original, but this diagram is basically the blueprint for a modern goal-seeking system. You can still see Boyd's original 4 steps right in the middle, but there are 2 major additions here that change everything.
The first big upgrade is adding an explicit intent phase. Now, this is so important because it formally separates the what from the how. The orient phase still figures out what's going on, but now it formulates a goal, an intent. It then hands that goal over to the decide phase, which is now totally free to figure out the best possible actions to achieve it. That separation is where all the flexibility comes from.
The second huge upgrade is this whole bottom layer, the evaluation and learning engine. Think about it. In the original loop, all that learning was happening inside the pilot's brain. It was implicit. By making it an explicit part of the architecture, we're building a dedicated feedback system. This is the part of the loop that constantly asks, okay, how did that go? Did it work? Could we do better next time? It's what allows the system to get smarter all on its own.
So this learning engine is basically the system's brain humming along in the background. It does 3 really important jobs. It feeds knowledge and context to all the other phases so they can make better decisions. It analyzes the results of every action so it can learn from its mistakes and successes. And maybe most importantly, it creates the perfect logical place to plug in artificial intelligence to supercharge the whole shebang.
Okay, so we've mentioned AI. Let's dig into that. How do we actually use artificial intelligence to bring this framework to life and make it genuinely smart?
And look, this isn't just some academic theory. This is based on real research from a collaboration between Sweden's Blekinge Institute of Technology and the tech giant Ericsson. They've laid out exactly which machine learning tools can be used to power the different parts of this loop. Here's a quick look at how it works. To translate a big fuzzy intent into concrete actions, they can use decision trees. You can think of those like super smart flowcharts for making choices. To figure out if the system even has the tools for the job, they use something called fuzzy sets, which is a great way to handle situations that aren't black and white and just find the best fit. And for the learning part, they use deep Q-learning. This is really cool. The AI basically plays a game against itself over and over, trying different things to discover the absolute most effective strategies over time. Each tool has a very specific job to do. So we've got the framework from a fighter pilot. and we've got the AI tools to make it run. But let's zoom out. What does this all actually mean for the real world? Why should we even care about building systems this way? Well, the advantages are just massive. First, you get incredible flexibility. The system isn't stuck with one rigid plan. It can pivot and adapt to whatever's happening to achieve its goal. That flexibility enables true human-machine teaming, where people can set the high-level goals, the intents, and the AI can handle the nitty-gritty of execution. Third, because of that learning loop, you get self-optimization. The system literally gets better at its job over time. And finally, you get this amazing compositional power, which means you can stack simple intents on top of each other to tackle incredibly complex problems.
And this is so important. The researchers themselves make it really clear that the goal here isn't to automate people out of a job. They state it directly. The whole point is for the AI to support human actors in creating knowledge. This is all about augmenting our own abilities, making us better and more capable, not replacing us.
So I'll just leave you with this one thought. For so long, our relationship with our technology has been like a commander giving strict, unthinking orders to a soldier. But this framework, this, shows us a future where it's much more of a partnership. And it makes you wonder, what becomes possible when our most complex systems can not only follow our orders, but can actually understand what we're trying to achieve? What can we build then?